Young people, welcome back. BMB in the house, y'all, and we got a nice one for you. If you are here and you're new, we are already in chapter 11, and let's actually take a look at it right now, guys. Chapter 11, section 2, rational functions. Objective 1, identify excluded values. Objective 2, identify and use asymptotes to graph rational functions. Woo! All right, guys, so special one today. We're actually going to try our best to stay under 30 minutes, whereas this handout, and especially moving into the deeper chapters, chapter 11, 12, even chapter 10, some of the handouts can take a little long. So shorten 30 minutes, and we're actually going to pull in some help from the internet. So concept, rational functions, skill, identifying, and graphing. All right, let's get this bad boy started because we got a lot of fun today, y'all. All right, so there's your handout. You got the graphing at the bottom. The top section, though, guys, the top section is pretty cool, and the reason why is it's an explanation, understanding thing. So if you're here, I'm sure somebody talked to you, hopefully, about the lesson that you're watching this video on. And when it says excluded value, so if I exclude you from my party, you ain't coming in, you're not allowed. So state the excluded value for each function. X cannot equal 0. That is what is excluded. Meaning X can't be 0 because you can't have 0 in your denominator. For number 2, it is 2. And for number 3, it is 6. So already, I'm gonna get a pause and give a little bit more explanation for that. So, as you can see, quick and easy, because -6 for number 3, y'all. Because number 1, X is 0, you'll have 6 divided by 0. Punch that in your calculator, see what happens, right? For number 2, 2 minus 2 will be 0. So when X is 2, your denominator is 0. No, you can't have that. And for number 3, of course, -6, because 6 plus 6 would be 12, and yeah. But positive 6 in your numerator. So as we continue, you'll recognize that your goal is to find out exactly what value will give you 0, because you can't have 0. That's the excluded value that we're looking for. All right. So hopefully that makes sense. If it didn't, rewind and listen to it again. Here we go, guys. So, where are we at? Number 4, -4. Number 5, -8. And of course, when we get to number 6, we recognize, hold on, that's 2x minus 14. So let me go ahead and do a little bit of extra work here. I'm going to factor out my 2. And factoring, we're going to be using all day long for the rest of this book, right? Hopefully you got that down. What goes into 2 and 14 evenly? 2. So the binomial is now x minus 7 because we factored out our 2. So in that case, x cannot equal 7. And you notice right there, I'm writing it as x cannot equal 7. Whereas above, we're saying x equals 7. State the excluded value. So the excluded value is 7, x equaling 7. I just learned it a special way when I was in school, so I just use that cannot equal 7. X does not equal 7. But you're getting it, and you got it. I hope you are. Next section here, guys, all 3 of those are going to need to be factored. So with number 7, y is equal to x divided by 3x plus 21. Go ahead and recognize 3 and 21. So taking out your 3 and x plus 7. So again, if x was -7, that should be negative. Pay attention, Mr. Kraft. 9x minus 36, x minus 4. Of course, 9 times x and 9 times 4 will give you 9x minus 36. So in this sense, x cannot equal 4. And for the last one, 5x plus 40 will become 5 times the quantity of x plus 8. And again, I cannot have -8. So guys, as you've seen at least 3 times already, be careful with your signs, right? But all of that because we're getting into the real deal Holyfield. Meaning, here comes the second portion of the handout. So, identify I love that word, asymptotes of each function, then graph the function. So, before we do, we're going to talk about just the vocabulary. Take some time, look it up in the back of the book. It's called a glossary. Get a pause. Take some time, watch some YouTube videos. That's why you're here. I appreciate you coming to this page. Appreciate you looking at this, but I am one of many that are here to help you out. And trust me, I'm good, but there's people that are good too out there. You know, I sure ain't the best, but I'm better than a lot. So make sure you go look it up, watch a video on it, because I'm just going to give it to you. I'm going to. That's why we're here. You're here to get a little bit of help and understand what's going on. And definitely, if you don't get it the first time, first attempt in learning. Fail. Look it up. First attempt in learning. So if this is your first attempt, trust me, it could be a little challenging. But let's get it started. That was me waiting for you to go look up the word. Vocabulary, right? So, get it going. All right, so if x was equal to 0, or y was equal to 0, what do we got? Now, I'm pulling in Desmos from the jump. If you haven't used Desmos, you haven't watched my videos, or you haven't had a teacher that likes to use other things to help you learn, Desmos is great, guys. There it is. So we're going to use it to actually get the answer. Now, if I were to plug in x is equal to 3, check it out. Let's go. Now, we had 3 in there, it was the 1/3, right? But recognize the function. You recognize that graph that hugs those axes are isotopes, all right? It will never hit. Now you can see I'm gonna start dragging and pointing out some points. Zooming in, zooming out. Guys, this is what I mean by you gotta play with it a little bit, all right? So just looking at it now, as it switches from side to side, I can pull some points off of there, and I can pull points off of there so that I can use them in the table to graph the one on the handout, all right? Or I can just, looks like this, swoosh, swoosh, and be done. But let's be a little bit more accurate. And what I mean by accurate is, there we go. So when x is 3, 2.98, there we go. When x is 3, y is 1/3, right? 0.33333. That's what 1/3 is. Right here, when x is 1, well, guess what? Come on, it was so hard to get it. Y was 1, but you saw it, right? So I'm basically taking my mouse and I'm dragging it along the graph to see the points. See the little red point? Boom. When it's 6, right? X is 6. What do we get? So I'm literally using Desmos to help me understand where the points are that I'm going to use to graph this function. So, and that's just me zooming in. You can notice the x and y axis goes from being 2 to 5 to halves now, right? So there's a very good picture of it. And again, when x is half about, right? Keep on sliding, there we go. Just showing a few points, right? Zooming it back in to try and get a better view, because I do get it. Here it comes. You'll get it, right? Here it comes. Oh, not nice at all. Let's try that again. So it's going to hug the y-axis, and it's going to hug the x-axis, but it will not touch it, right? Now remember, we have the coordinate point 1, 1. When x is 1, y was 1, so that's an easy coordinate I can use. But you'll see right there where it's just getting closer and closer to y and closer to x, right? So I know I have my excluded values, what it can never be. But pretty much, guys, like I said, Desmos is going to show me what it looks like, but I can use coordinate points, values plugged in for x to get a more accurate picture of the graph. So that's why for number 10 we plugged in 1 for x. And of course 1 divided by 1 is 1, so y would be 1, 1, 1. So here it is again. The Desmos, let's get the correct function. So no longer y is equal to 1 divided by x, but I'm going to go ahead and get the new function. Y is going to be equal to, well, careful. Yeah. And that's the thing, you got to play with Desmos. So if your teacher doesn't do it, it'll be fun, just videos, instructional videos for everything out there. But y is equal to 3 divided by x. So again, what values can you not have for x, right? No such thing, x can't be 0, right? So that's why it will always hug. See, even at 6, it keeps getting closer and closer. But let's go ahead and start getting these values though, right? Because you can plug in any value for x except for the ones that are excluded. You can't have 0, right? So if x was 1, if x was 2, if x was 3, that's basically what the graph is showing us. And I can, there it is. When x is 2, there it is, 1.5. All right? So that's a coordinate point. It's going to help me graph this correctly, right? When x is 3, right? You're going to see that in just a second. And of course, if x is 3, there's my first point. First coordinate. See another one. And of course, 3 divided by 3. Anyone? Anyone? You got it, right? So, and again, guys, the Desmos is useful for more than just linear functions, quadratic functions, rationals that we're looking at right now, right? So always, if you need to pull up Desmos, see it, and then use what you see to help you understand what you're doing, right? So right now, what am I doing? I'm figuring out, according to Desmos, what are some of these points? Well, if x is 4, that's 3/4, or 0.75. So I could use that again to graph it. Not quite 1, but 0.75, so it's going to get really close. So and there's 2 points, but I could get more. And I don't know why I don't have 3 yet, because you literally can see that 3 divided by 3 is 1. So let's see if I add that to number 11. And of course, if I was in class, I'd literally have my student come up, grab the stick, and have them use it to understand what's happening with this function, right? So, what's that dash line for? To show the breakpoint. It will never get there, right? Asymptotes. So, and here comes my table. So again, we started up here, but I'm removing it over there, just so that we know when x and y, and this could work for any graphing, right? Third degree polynomial, second degree polynomial, linear, you pick it, right? When x is 1, of course, 3, because 3 divided by 1 is 3. Am I really going to show that? I thought we showed it. Let's show it again, right? And find it, go get it. There it is. All right, guys, so I did all of that work and I went poof, and it magically appeared. No, Desmos is outstanding. The table that you see up there now, you can create. So I steal that table and I put it on my graph, on my handout, right? You see the coordinate points, they're identified there. So instead of me walking you through, because it isn't a Desmos video, it's a lesson 2 from chapter 11 video, right? So just showing, again, what we were writing in blue on the Desmos activity. Boom, bang, and all right, we got them all? No, because we still got one more to do. But 1, 3, and of course, again, when x is 3, 3 divided by 3 is 1. So if x is 3, 1, 2, 3, and go up 1. Boom. And again, guys, I'm recognizing that it's just, there it is. I only needed 2 points. And then, of course, it's just going to get closer and closer to the x-axis. as it gets larger, right? As x gets larger, it gets closer to the x-axis. As y gets larger, it gets closer to the y-axis, but we won't ever get there. Really important now, we're gonna get our negatives. Remember, even when we did linear and when we did second degree, quadratics, right? 2 positives, 2 negatives, and 0. We're excluding 0 now, but when x is -3, we get -1, because 3 divided by -3 is -1. And of course, when I plug in, excuse me, -1 for x, 3 divided by -1, -3. So again, there's my beautiful. Don't you say a word, it's nice enough. I want to see you try and get perfectly curved lines on your coordinate plane. Yeah. Perfectly curved lines on your coordinate plane. But you want to hear me say it again? Perfectly curved lines on your coordinate plane. All right. So we got one more, guys, and really recognize now what's going to happen here. So you notice on number 11 on the axis, those dotted lines, those asymptotes were drawn on the axis. Well, not so much here now, guys. Here I'm recognizing x, no, it can't be -1. So literally I go to -1 on the x-axis and I say, nope, can't be here. It can never be this value. That's my excluded value, right? And of course, same thing for y, because, doesn't want to equal 0. And then of course, we start picking points again. I don't need to pull up Desmos, but of course, pop that into Desmos and I'm going to see exactly what the graph looks like. But I'm using my brain to go, okay, what values can I use for x? If I use 0, oh, that just gives me 2, right? 2 divided by 1. If I plug in 3, oh man, hold on. 3 plus 1, that would be 4. 2 divided by 4, that's the same as 1/2. Okay, I can graph 1/2. So I want to use values that are going to give me coordinates that are comfortable to graph. I'm not trying to graph 1 and 3.7825, right? I'm not trying to graph 3 and 1 and 7/15, right? No, pick values that are going to make your graphing on the coordinate plane easy or possible, right? So, and of course, pull up Desmos and see what it really looks like. But 2 positives, and of course, I'm going to go for the 2 negatives. So here it is where I use 0, which this time I can because that's not an excluded value. Remember before, I was like, oh, we're not using 0. You always use 0. That's what you said in chapter 9. I don't remember what chapter it was, but you know what I'm talking about. So, boom, bang, pow. Let's do the negatives in a different color. Okay. So -2 when you plug in. All right, what do you get? -1. What's 2 divided by -1? You got it. -2. So there's a coordinate. And I can graph that -2, -2. Old school, easy school, guys school. And what other value can I use this negative that will work out? I don't know. How about -3? Why -3? Because -3 plus 1 will give me -2. And of course, -2 as the denominator, you're gonna get 2 over -2. And guess what that is? -1. So here it comes. 2 divided by x plus 1. What value would I like to choose for x? What did we say? -3. You got it. -3 plus 1 is going to give you -2. So I get 2 divided by -2. And I like it. I love it. I want some more of it. Let's get it. All right, guys. So I got one of the coordinates in red and another coordinate here in blue. It's all good though. Go ahead and connect those dots. La 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 la. I love showing my age on here. Peter Herman's Playhouse. You already know. Way before Mystery Man. You already know. The sphincter rules, baby. All right. Let's get it. So guys, definitely the meat and potatoes. When you got to that portion of the handout, definitely Desmos was a key contributor to the explanation of what we are doing here. So let's see what we got. And again, guys, I made a promise. We're not going to be on here for 30 minutes, 45 minutes. Well, we might be on for 30 minutes, but you see what I'm saying. So, borders. X cannot be 2, so 1, 2. And of course, we don't want y being 0 because, no way. All right, and again, choose my values carefully. If I have x equaling, I don't know, maybe 3, because 3 minus 2 is not 11, 1, right? So, and by doing that, well, let me slow down. X can equal 1, what else? X can equal, I already said it. Well, I didn't say -4 yet, but -4 is good. And there it is, 3. So I said 3 earlier just because, again, as I'm looking at this problem, my mind is already boom, 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 I'm breaking things in. So when I plug in 1, and I should show my plug in here, 3 divided by parentheses minus 2, plugging in 1. 3 divided by 1 minus 2 now, which will give you -1. So let me go ahead and slow down so we can catch up. And 3 divided by -1 is just -3, so there's my first coordinate. Not going to stop there. What about -4? So when I chose -4, I think 3 would have been a better one. Let's see what we do here. Excuse me. And there it is. The value we're going to choose this time. Guys, remember, you can choose any value. Choose well, right? -4. All right. See what's happening with the BMB here. Thinking about it? No, not really. I was thinking to Adam. I don't know why I was thinking I was going to get 2. I should slow down. Had way too many mistakes already this morning, huh? Did I say morning? You know what time it is where I'm at. So, got them? One more. 3 divided by parentheses minus 2, and my last value, +3. And of course, we talked about this one. 3 minus 2 is 1, so we get 3 divided by 1. 3 divided by 1, you already know. It's going to leave you with just 3. So, bam. Get it? Got it? Good. Go ahead and plot your points, guys. Again, 2 points, 4 points, 6 points, however many that are needed to correctly graph your points, or I should say generate your points, and then we're graphing them. So that's what's happening now in green. Looks like we got 1, -3. Then we got our -4, 2. Or I'm sorry, half, not 2. So again, guys, you do notice I've got 2 on one end and 2 on the other end. So again, in my mind, as DJ the Chicago Kid, I'm not crazy. I got it. But I am recognizing I need 1 more. And that's what that box is for, right? So felt this coming. And now that it's here, as long as x is going to be greater than, and this is why we got the blue line, the asymptotes, right? 4. And the reason why I say 4 is because we kind of know what happens when I plug in -4. Well, what if I plug in something greater than 4? And here it is, 5, 6, or 7, right? We're going to go ahead and write this out. Get it, got it? There we go. 5 minus 2 is 3. 3 divided by 3 is 1, guys. So again, choose wisely, right? If you would have plugged in 7, if you would have plugged in 1, it would have gave you something you might not have been too comfortable with. Definitely the Desmos, right? Because in Desmos, you can put it in the table and it's going to calculate it for you, and it's going to put it on the graph for you. So this freehand, as we like to call it, right? We're freehand graphing this, plugging in points. Finding out the value of y when x is equal to 6 or 5, right? So exactly, have fun. Pick them well, because ultimately you're not wrong, you're just not correct. All right, so Have fun, guys. Enjoy it. Got one more for you? Of course I do, right? So, little Desmond's there for you because I am always going to lead you to success. Have a good one, guys.